Hey Fast Track, so today's video is about composition of functions. So make sure this title makes it to your table of contents and also on the page where you're going to take your notes today. Okay, so let's start with example 1. So if f of x is equal to 5x minus 2 and g of x is equal to negative 2x minus 7, let's evaluate the following. Okay, so here's how you read this. It is f of g of 1. So in other words, you read it from left to right. And let's try that one more time. So it is f of g of 1. Okay, so this is composition of functions. Whenever you evaluate a function and whatever you get, you put that inside of the other function. So here's how you do these problems. You always start with the inside. So notice that the inside is g of 1. So we're going to take our g of x, which is negative 2x minus 7. And we are going to substitute negative 1 every time we see an x. So let's do that. So negative 2 times 1 minus 7. And let's simplify. Negative 2 times 1 is negative 2 minus 7 is negative 9. Okay, so for g of x, whenever x is 1, the y value is negative 9. So after you evaluate the inside, we are going to replace that g of 1 with a negative 9. So let me choose another color for this. So again, I evaluated g of 1. I found that g of 1 is negative 9. So you replace the g of 1 with negative 9. And I'm going to do that at the bottom. So now I'm doing f of negative 9. So I'm going to take my f of x. And I'm going to substitute negative 9 every time I see an x. 5 times negative 9 is negative 45. Minus 2 is negative 47. So f of g of 1 is negative 47. Let's try the second example. So the second example is g of f of negative 2. So remember, you always start with the inside, and the inside is f of negative 2. And once we get for that, we are going to substitute that into our g of x. So let me start with the inside and substitute negative 2 every time I see an x for f of x. So if you simplify, 5 times negative 2 is negative 10. Bring down your minus 2, you get negative 12. So f of negative 2 is equal to negative 12. Okay, make sure you guys know how to interpret that. So here's what this means. For your f of x function, whenever x is negative 2, your y value is negative 12. So make sure you know that that right there is an ordered pair. Okay, so now that we have our f of negative 2, we're going to go back to our problem and replace this f of negative 2 with negative 12. So now I'm doing g of negative 12. And I'm going to substitute negative 12 for g of x every time I see an x. So negative 2 times negative 12 is positive 24. Minus 7 is how much? 18. Let me double check. Last time I made a mistake. It's actually 17. So g of f of negative 2 is equal to 17. So make sure you don't box this answer and make sure you go all the way to the top of the problem and put it at the very beginning. Okay, so remember, composition of functions is whenever you evaluate a function and then whatever y value you get, you substitute into your second function. And then we'll see a more real world example once I show you the next part. So notice that for example 2, I gave you two graphs. So notice that the black bold line is f of x and this gray line is g of x. So make sure you know the name of your functions. Okay, so we're going to evaluate the following. So for a, we are going to evaluate f of g of 0. So remember, we always start with the inside. So remember, the inside here is g of 0. So in other words, we're going to look at g of x, and whenever x is 0, we are trying to find the y value. Okay, so on the side, I'm going to do g of 0. So I'm going to look at g of x, and whenever x is 0, your graph for g of x is up here at y equals 1. So g of 0 is equal to 1. So remember, this is the x value. You're trying to find the y value. Okay, so g of 0 is 1. So therefore, we are going to evaluate f of 1 now, because we are replacing the g of 0 with a 1. I should have left more space in here, but we'll get it done. So let me move, oop, not that. So let me move this f of 1 real quick. Okay, so now we're looking at f of x, and our x value is 1. So we are trying to find the y value. So we are looking at f of x, which is the black line, and our x value is 1. When x is 1, which is right here, your f of x is down here at this y value, which is -1. So the answer to letter A is -1. Okay, if that confused you, let's go ahead and try problem B. So we are evaluating g of f of 3. So remember, we're going to do the inside first. The inside is f of 3. So f of 3. So we are looking at f of x. Make sure you know that this is the x value. You're looking for the y value. So whenever x is 3, your graph is right here at the same spot, and the y value there is 0. So again, whenever x is 3, f of x is right there, and that y value there is 0. So f of 3 is equal to 0. So now we're going to replace our f of 3 with 0. So now you evaluate g of 0, and then you will be done. So remember, the 0 will be your x value. You're looking for the y value. Okay, so now we're looking at the gray graph, and whenever x is 0, the graph is up here at 1. So B is +1. Okay, so letter C, we're evaluating g of f of 3. So we start with the inside, which is f of 3. So we are looking at the black line. And remember, whenever the x value is 3, we are looking for the y value. So whenever x is 3, the f of x is right there, which is at 0. That's the y value right there. So now you evaluate, now you replace the f of 3 with 0. So now you evaluate g of 0. And then we will be done. So for g of x, which is the gray line, when x is 0, the graph is up here at y equals 1. So our final answer here is +1. So I need you to pause the video. I want you to try D, E, and F on your own, and then unpause the video once you have them. Okay, so hopefully you've actually paused the video and you tried them. So let's go ahead and see if you are correct. So let's evaluate problem D, which is f of g of 1. So let's do the inside first. So g of 1. Okay, so your g of x is the gray graph. So whenever x is 1, g of x is up here at +1. So we're going to replace this g of 1 with 1. So we are now evaluating f of 1. So now we're looking at the black graph. So we are trying to find the y value when x is 1. When x is 1, your f of x is down here at -1. So letter D was -1. Now, problem E, we're evaluating g of f of 2. So we start with the inside, we are doing f of 2. So the x value of 2 is right here, and then f of x is down here at -2. So that's your y value. And now you are replacing this f of 2 with a -2. So then you have to do g of -2. Okay, so now we're looking at the gray graph, and your x value is -2. You are trying to find the y value. X is -2 right here, and g of x is up here at +2, making the answer for letter E +2. Okay, problem F. We are evaluating f of g of -3. So let's start with the inside. So our x value is -3. We are trying to find the y value. X is -3 right here, and we are doing g of -3, so that's the gray graph. So when x is 3, g of x is up here at +3. So now we're replacing this g of -3 with +3. And we are finding the y value now, looking at the black graph. X value is equal to 3 right here. F of x is right there, and the y value there is 0. So the answer to letter F is 0. Okay, so hopefully you got all 3 of those right. So let's keep going. Okay, so now we've done composition of functions using equations. Example 2 was composition of functions using a graph. Now we're going to do composition of functions looking at 2 tables. So remember, these are just different representations of functions. So we are doing the exact same thing for all of these. Okay, so notice that the first table represents g of x. The second table represents f of x. So make sure you keep that in mind. Okay, so if you look at letter A, it says parenthesis f, a little dot, then a g, close parenthesis, open parenthesis 2. So you have to know that that right there is the exact same thing as I did on the other slide. So f of g of 2. So make sure you know that these two are equivalent. So let's do A. Again, you start with the inside. So we're doing g of 2 first. So we're looking at g of x, which is the table at the top. Our x value is 2. We are looking for the y value. So when x is 2, the y value is 3. So then we're going to replace this g of 2 with a 3 and then evaluate our f of x. So now we're looking at the second table, and our x value is 3. We are trying to look for the y value. So whenever x is 3, the y value is 9. Okay, so our final answer is f of g of 2 is equal to 9. Okay, so letter B. F of g of 1. So let's start with the inside, which is g of 1. So we're looking at g of x, so the first table. Whenever x is 1, your y value is 9. So now let's substitute or replace the g of 1 with a 9. So now we are doing f of 9. So we're looking for the y value whenever x is 9. We're looking at f of x. The x value is 9 again. So whenever x is 9, the y value is 6, making our answer of f of g of 1 6. Okay, so go ahead and pause the video, try the remaining problems. Let's see if you can get them. Okay, so now that you've tried them, let's go ahead and complete them. So real quick, letter C, f of g of 9. So looking at g of x, when x is 9, the y value is 12. So now I'm going to do, I didn't even write it down. So g of 9 is equal to 12. So then I do f of 12. And I'm looking at f of x, so the second table, when x is 12, the y value is 5, making our final answer 5. Okay, letter D. f of g of 5. So let's start with the inside. So g of 5, g of x is over here. When the x is 5, the y value is 6. So then we do f of 6. Looking at f of x, when the x value is 6, the y value there is 7, making the answer to letter D 7. Okay, letter E, g of f of 6. So if you start with the inside, which is f of 6, looking at this table, whenever x is 6, the y value is 7. So then you do g of 7. For g of x, when x is 7, the y value is 4, making the answer to letter E 4. Okay, letter F. F of g of 7. So if we start with the inside, we have g of 7. Whenever x is 7, the y value is 4. So then you do f of 4. For f of x, when x is 4, the y value is negative 3. Okay, for letter G, we're doing G. We are evaluating G of f of 12. So f of 12 is 5. So then we do G of 5. For g of x, when x is 5, the y value is 6. For letter H, we are evaluating g of f of 3. If we start with the inside, is f of 3. That's equal to 9, so then you do g of 9. So for g of x, when x is 9, the y value is 12. Okay, so here's where we use composition of functions. So prove that f of x and g of x are inverses. So in the past, if I ask you that if these two are inverses or not, you have two ways of doing it right now. You will graph f of x, you will graph g of x, and they should graph across the line y equals x. Another way you could have done it is manually. You would have taken f of x, you would have switched the x and the y, and you would have solved for y. And if it gave you g of x, then you would have said, yes, those are inverses. But today we are going to use composition of functions to help us prove if functions are inverses or not. So here's how you do it. So we have to do the following. We have to do f of g of x, and our answer should be x. And then we have to do it the other way around. We have to do g of f of x, and we should also get x. So once you do the composition of functions and both of these give you x, then they are inverses. So if on a test I ask you to prove if these two are inverses or not, you would have to do the following. Okay, so let's start. So let's start with f of g of x. So notice that we no longer have an x value here. So this is a little bit different. So for these type of problems, we are going to take our whole g of x function and put it inside of f of x. Okay, so we're going to take our inside, which is g of x, and we're going to put that inside of f of x every time we see an x. So we have 5 parenthesis x plus 2 over 5 minus 2. So let's simplify and see what we get. 5 over 5 cancels out, reduces to 1. So I'm going to bring down x plus 2, bring down minus 2. 2 minus 2 is 0, and I get x. Okay, so as you can see, the first part is looking good. Now let's do it the other way around. G of f of x. So notice that the order switched. So now I am putting f of x inside of g of x. So f of x is going to go inside of g of x. So let's try it. And let's simplify. Negative 2 plus 2 is 0. Then I have 5x over 5. 5 over 5 reduces to 1, so I bring down my x, and notice that g of f of x is also equal to x. Therefore, f of x and g of x are inverses. So again, we use composition of functions to prove if two functions are inverses of each other or not. So keep in mind that you have to do both ways. So go ahead and try this one. Are f and g of x inverses or not? Okay, so here they are. So I'm gonna try f of g of x. So I'm gonna put g of x inside of f of x. So I'm gonna put all of this every time I see an x. So I'm going to simplify. Negative 4 times negative 1 over 4x is positive 1x. Negative 4 times 2 is negative 8. Bring down the plus 8. If I keep simplifying, I bring down the x. Negative 8 plus 8 is 0. So f of g of x is equal to x. So we are going good, so let me keep going. Let me do the other way around. So now I am putting f of x inside of g of x. So I'm going to put this for x. Negative 1 over 4 times negative 4 will give me positive 1x. Negative 1 over 4 times 8 will be negative 2. I bring down my plus 2. Negative 2 plus 2 is 0, so notice that g of f of x is equal to x. Therefore, f and g of x are inverses. Okay, so here's the very last one. So go ahead and pause the video, go ahead and prove if these two are inverses of each other or not. Okay, so for the left side, we are going to put f of x inside of g of x. So we're going to put all of this inside of x. So negative 18x minus 8 plus 1. If I simplify, I get the following. So notice that I did not get x, so therefore I can stop here and say f of x and g of x are not inverses.